Hello guys, it's Johnny time and welcome to another smart contract hacking tutorial. Today we're going to solve the second challenge in Damn Vulnerable DeFi Naive Receiver. I will show you how I approach this problem and how I solve it from the beginning to the end, complete walkthrough. So I hope you are excited, and without further ado, let's get started. So this is the second challenge in Damn Vulnerable DeFi Naive Receiver. If you don't know what is Damn Vulnerable DeFi, check out my other videos in this playlist of what is Damn Vulnerable DeFi, how to get started, and the previous challenge as well. So in this challenge, there is a pool with 1000 ETH in balance, and it offers a flash loan. It has a fixed fee of 1 ETH per flash loan, and we have a user that deployed a contract with 10 ETH in balance, and it's capable of interacting with the pool and receiving flash loans of ETH. We need to take all the ETH out of the user contract, if possible, in a single transaction. So in this exercise, unlike the previous one, we don't attack directly the pool, but we take the user that is utilizing the pool. So we don't need to steal this 1000 ETH, but we need to drain the user 10 ETH. So the user's contract that receives the flash loan, we need somehow to exploit this contract so he won't have money. And we have a bonus challenge to make it in a single transaction. So before we deep dive into the solution, let's take a look at the contracts and the JavaScript test files to understand the state. So I'm jumping over to the contracts folder in Damn Vulnerable DeFi version 3, Naive Receiver, and we can see that we have two main smart contracts. So the first contract is Naive Receiver Lender.pool. This is a flash loan smart contract which basically allows users to receive flash loans. As you can see, it implements the IRC 3156 flash loan lender, and the token that it provides flash loans is mock ETH. This is basically an address that represents like native ETH on the blockchain. It's used in the past by Bancor and other projects, so it's kind of like a standard, but this token means nothing. This address cannot be retrieved by anyone, so it's just to mock a token of ETH, like flash loan of ETH, instead of native ETH. And here we can see the fee, as were mentioned in the description, 1 Ether, and this is the callback success. So the receiver of the flash loan, the contract who implements the flash loan, need to return this hash, this result of KEKAK256 function, in order so the callback will succeed. Here we have two functions that are implemented. They are part of the IRC 3156 interface, max flash loan and flash loan fee. And this is the flash loan function. This is the function that anyone can call in order to request flash loan from this pool that has 1000 ETH in balance. We can see that we pass 4 parameters. First is receiver. It's an address that implements the IRC 3156 flash loan borrower, not the lender, the borrower, the one who receives the flash loan. So he will receive the flash loan, and the callback will be triggered to this address. And we receive the token that we want to flash loan, an address, UN256 amount, and bytes 32 call data. So this data will be passed with the flash loan, with the callback to the receiver. And this is pretty straightforward. We first make sure that the token is ETH because we don't support any other tokens. We check the balance before. We transfer the token safely using the safe transfer lib to the receiver, to the address of the receiver, the amount that was requested. And this will revert if the amount is too much, if it's bigger than the amount that the contract has, because we use the safe transfer ETH. Then we make the callback, okay? So we call the receiver with on flash loan. This is the function that we are going to call together with all this data, and we make sure that the return data of this function is this hash that we defined earlier on, the KEKAK256 for this selector. Now, then we need to validate that the receiver paid back the loan plus the fixed fee, which is 1 Ether. So we make sure that the user who took the loan basically return the money together with the fee, which is 1 ETH. So this is the contract that basically allows people to take flash loans, and this is the other contract of the user that was mentioned before that basically was loaded with 10 ETH, and we need to make sure to drain this contract, not the pool, but the flash loan receiver contract. And this contract also have this kind of on flash loan function, which is the function that is being triggered by the callback here. So once someone take a flash loan, this on flash loan function will be executed. This is the callback function. Now this receiver implemented this function, and as you can see, it receives address, token, amount, fee, and bytes data. So it makes some checks. It makes sure that the pool, the caller, the message sender is basically the pool contract. So it can receive flash loans only from this particular pool smart contract that is being configured upon construction over here. And you can see that it makes sure that only the token should be only ETH, so it is not allowing to receive flash loans that are not ETH. And he basically calculates the amount to be paid back, which is the amount plus the fee. He makes this kind of a hook over here, which does basically nothing, and it transfers back the ETH, the amount to be repaid, which is the amount that he borrowed plus the fee, and returns the hash. So the flash loan transaction won't be reverted because we know that the pool checks this hash to make sure that the transaction was succeeded, and it implements the right interface in the on flash loan function. So this is actually the contract that we need to attack, and this contract will have 10 ETH according to the description over here, and we need to drain those ETH and do something with it. So let's see what we need to do with it. We will jump into the test file. We go to naive receiver, and this is the test file, and now we can look at the state and try to understand what's going on here. These are the two constants, right? So we have 1000 ETH in pool and 10 ETH in the receiver account. Here we have three signers: deployer, who deploys probably the pool, the user is going to deploy the receiver smart contract, and the player is our account. We are the malicious actor that needs to hack the user. Here we set the factories of the contracts and deploy first the pool, then we load the pool with some ETH, with 1000 ETH, and we receive the ETH address, the token address ETH. As you remember, it's over here. This is the ETH address, this 0xEEEE address. So we receive it into a constant. Then we do some sanity checks, some unit tests to make sure that the pool is correct. And we deploy the flash loan receiver, right? So we take the factory and we send some ETH to the receiver, this 10 ETH, and we do some tests on the on flash loan function, and we make sure that the balance is correct. So these are all unit tests that we don't have much to do. It's just to set up the scenario and make sure that the state is correct. Here is the execution section. Here we have to write our exploit to achieve this state in the after section. Now the state that we need to achieve is that the receiver address, so this flash loan receiver smart contract, has 0 ETH, even though we sent here 10 ETH to it, so we need to drain it, and we need to make sure that all this 10 ETH is being transferred to the pool. So the pool eventually needs to have the initial balance in the pool plus the balance in the receiver. So it's gonna have 1010 ETH. Now, how the hell we gonna do it? Do you guys have any ideas? So this is the point where you need to be creative and start activating your attacker mindset. Now, if you feel that you need to pamper your skills in order to solve this challenge, in order to be able to adopt and activate the attacker mindset and basically solidify your foundation, your basics in smart contract hacking, you can certainly do that by taking a structured, practical, online smart contract hacking course that will help you to build this solid foundation to be able to solve those challenges and move forward in your career. After completing successfully the course, you will become a certified skilled smart contract hacker. And if you want to learn more, I will leave a link in the description below. So the way we're gonna basically exploit the flash loan receiver is we're going to exploit an access control vulnerability, which one of the vulnerabilities that we are covering in a smart contract hacking course. So the flash loan receiver implements this on flash loan function that receives 5 parameters, right? The first parameter is an address, and this is basically the message sender that initiated the flash loan. And as you can see, the on flash loan, the receiver contract just basically just ignores this first address, this first parameter. And this is very bad because this parameter is basically telling the contract what is the address who initiated, who requested the flash loan, right? The message sender who called the flash loan function. And as you can see, he ignores it. He doesn't even save it into a parameter and doesn't make any sanity checks, any required statements, any reverts around this address, which means that anyone, any address can initiate a flash loan on behalf of this receiver, which means that I can, from my player account or my malicious account, call the flash loan function with the receiver parameter. I will just send the flash loan receiver smart contract as the victim, and I will basically request a flash loan on behalf of this flash loan receiver smart contracts. And because he did not check who's the one who initiated the flash loan, I can just request as many flash loans as I want on behalf of this smart contract. Now, why is it bad? It's simply bad because flash loans cost fee. Every flash loan costs 1 ETH, which means that every time I will call a flash loan on behalf of this flash loan receiver contract, he will have to pay 1 ETH fee. So I just need to call it 10 times in order to drain those 10 ETH and make sure they go directly to the pool. So now that we activated the attacker mindset and we found a way to exploit this access control vulnerability, now it's time to implement our exploit. So we need to call the flash loan function 10 times on behalf of this flash loan receiver, on behalf of this victim. Now, the easiest way to do that is basically to do a for loop in JavaScript. So for, and then I will do a let I equals 0, I lower and equals 10, right? And then I plus plus. So we basically do a for loop of 10 iterations, and we're just gonna request a flash loan on behalf of this flash loan receiver. So how we're gonna do that? We're just gonna do a wait pool. We're gonna connect the player account because we only possess the player account, the account that is basically making damage over here. We don't possess the deployer or the user. So making sure that we're sending the transaction from the player account. And then we call the flash loan function. So we are going to call the flash loan function to this pool. And we're going to send 4 parameters. The first parameter is the receiver, token, amount, and data. So the receiver is going to be here, the address of the receiver, right? The flash loan receiver smart contract. So receiver.address. The token, we want to use the ETH, but we don't have it over here in this block. So we'll have to copy this line of code. So now we have the ETH address in this constant variable, ETH, right? The next parameter is the amount. Now we don't need to request any tokens from the flash loan. We can just send 0 amount because the most important thing is that this flash loan receiver will pay this 1 ETH fee. So we can just pass here 0 tokens because we are not really interested in a flash loan. We just want to trigger the flash loan, so he will pay the fee. And the data is just empty, 0x, just empty data. We're not going to send any bytes to this data. This is supposed to be enough, and we, the player, are initiating a flash loan on the pool, but we're sending the receiver this kind of flash loan receiver contract, a vulnerable contract that has 10 ETH in balance and doesn't have access control, so we can just trigger as many flash loans as we want on his behalf. Now it's time to run the test and see if basically our exploit succeeded and we were able to drain this receiver smart contract. All right, guys, so I have a small mistake over here. Instead of I lower and equals 10, it should be I lower than 10, because if it's lower and equal, then we're going to call it 11 times, and we don't have 11 ETH in the receiver victim contract, so we need to call it only 10 times. So I change here this for statement over here from lower equal to just lower, and now we are going to go back to the terminal and run yarn naive receiver, and let's see if it works. And it worked, guys. We basically initiated the flash loan 10 times and drained the receiver contract and loaded the pool address. Now, this is cool, but we got even a bit better challenge, a bigger challenge, and if possible, we need to do it in a single transaction. And how can we do it in a single transaction if we need basically to call the flash loan function 10 times. Here we basically send 10 transactions because we have 10 iterations, and every time we send a new transaction from the player account to make this flash loan. So I want you to stop the video and think how you can basically level up this exploit and make it in one transaction instead of 10 transactions. So this one is 10 transactions, and we need to do it in one transaction. Okay, so let's see how we can do it. First, I'm going to comment out this code because it's 10 transactions and we want to do it in one transaction. And the way we're going to do it, we will have to deploy our malicious smart contract that will call the flash loan function 10 times, because we can just send one transaction, or actually, in fact, we can just deploy the contract and run the malicious code in the constructor itself. So it will be only one transaction. We're just gonna deploy our malicious contract. The constructor will be executed, and then the constructor, our malicious contract, will trigger the flash loan 10 times on behalf of the receiver. So in order to do that, I'm just gonna go to here to the player contracts and gonna create a new file, and I will call it attack naive receiver.sol. naive receiver.sol. So we are going to attack this naive receiver. We're going to create this malicious contract. So I'm just going to copy this line of code and this code basically and change it. So I don't need all these imports. I just need a Solidity version. I don't know this one. I'm just going to rename this contract. I will call it attack naive receiver. So this is our malicious contract, and we don't need any state variables. We do need the if as the constant because we're gonna pass it to the flash loan function. We don't need this error. We don't need these functions. So I'm just going to remove all this to clean it up. And in the constructor, we're gonna receive two parameters. The first parameter is the pool, and the second parameter is the victim that we are going to attack, that we are going to drain, right? So this is what we're gonna do. And we're gonna do a simple thing. We're gonna do the same for loop, but this time in Solidity instead of JavaScript. So instead of let, we're gonna use uint256 I, and then I lower, we will set it to 0, then I lower the 10, and I plus plus, right? So we have this for loop over here. Sorry, I instead of 1. Now, on this for loop, we need to call the flash loan function 10 times. Now, we need the interface of the pool so we can call the function. So I'm going to define here the interface of the pool, interface, and I will call it iPool. And we need only one function, actually, this naive receiver pool flash loan function. So I'm just going to copy here the function, clean it up a bit. This is the function that we are going to trigger, change it to a semicolon, and we don't need actually to implement the interface. We can just call it as an address and pass it as an address to the flash loan function, the receiver, instead of wrap it with the interface itself. And we're simply just gonna call here pool. So I will wrap it with the interface, so it will be our pool. So we will recognize the function and pool. And now we can basically call on this address the flash loan function. And the receiver is simply going to be the victim, right? The token victim, sorry. The token is going to be the ETH. The amount is going to be again 0, and the data is going to be 0x. That way, we're going to do the exact same functionality, the exact same exploit, the exact same attack, but this time it will be triggered through our malicious smart contract, so we can do it in only one transaction. Genius, right? Now, in order to make this beauty work, we'll have to deploy our malicious contract in a JavaScript file. So I'm just going to copy this line of code over here, the factory contract, and paste it over here. I will call it attacker contract factory. And here I will call it attack. This is the name of our contract, attack naive receiver. Right? And instead of deployer, it's going to be player because we are the ones who deploy this malicious contract, definitely not the deployer. So we have attack naive receiver. We need to make sure that it's the same name. So I will just going to copy it over here. And now that we have the factory, we just need to deploy the contract. So I will do something like this. We don't need even to save the contract address or instance to parameters. So I will just do attacker contract factory. .deploy, and I'm going to send basically the parameters for the constructor. So the first parameter is the pool address, the second one is the victim. So I will do pool.address, and the victim is the receiver.address. So we deploy the malicious contract together with those two addresses, and all the logic will be executed here on the constructor. Now that we have both our malicious contract ready and the JavaScript code that deploys it, we can just go and run the test and see if we can achieve the state in this different approach. So just yarn naive receiver, and let's cross our fingers. Yes, we made it. We were able to achieve the state in only one transaction thanks to this malicious smart contract. I hope that you learned something new and this tutorial helped you. If it did, make sure to subscribe to the channel for more awesome smart contract hacking content, and smash the like button so more people will find this video and learn smart contract hacking and help secure this Web3 DeFi space together. Thank you so much, and I will see you in the next video. Bye bye.